I have a dataset with 5 features, things that describe the data, and one continuous target variable, the thing we're trying to predict. Think of it like trying to predict a house's price, target, using its size, location, number of bedrooms, etc., features. I'm using scikit-learn's f_regression function. This function tests how well each feature individually predicts the target variable using a statistical test called an f-test. It gives me 2 important numbers for each feature. The f-statistic, a measure of how much variance is explained, and the p-value, the chance of seeing these results if there's no real relationship. These are the f-statistics I got from the f_regression. Each number represents how well that feature predicts the target variable. A higher number suggests a stronger relationship. These are the p-values from the f_regression. They tell me the probability that the relationship I'm seeing is just random chance. A low p-value, typically less than 0.05, means it's unlikely to be random, suggesting a real relationship. I've set my significance level, or alpha, to 0.05. This means I will only consider a relationship significant if there's less than a 5% chance that the results are due to pure randomness. This statement refers to the first feature. Its p-value is 0.002, which is less than 0.05. Therefore, I conclude there's a significant relationship between this feature and the target variable. Awesome. This statement is about the second feature. Its p-value is 0.21, which is greater than 0.05. That means I don't have enough evidence to say there's a significant relationship. Oops. The third feature has a p-value of 0.0001, much lower than 0.05. Therefore, there is strong evidence of a significant relationship. Woohoo! The fourth feature has a high p-value of 0.45. This means it probably isn't a useful predictor of the target and should likely be removed to improve the model. I have a dataset with 5 features, things I'm measuring, and one target variable, what I'm trying to predict. This array shows how much each feature individually explains the variation in the target variable. A higher number means a better explanation. This is the core question. Which features are important enough to keep in my model? The answer depends on interpreting the p-values. These are probabilities. A small p-value, less than 0.05, my significance level, indicates that the feature is likely truly related to the target variable. Let's investigate each one individually. Feature 1's p-value is 0.002, which is less than 0.05. Therefore, I conclude that there is a significant relationship between feature 1 and the target. Feature 2's p-value is 0.21, which is greater than 0.05. I would conclude that there is not a significant relationship between feature 2 and the target. Feature 3's p-value is 0.0001, which is much less than 0.05. This indicates a strong relationship with the target. Feature 4's p-value is 0.45, significantly above 0.05. This tells me it's not significantly related and can be removed from the model. This is implicit information from the p-value list. Its p-value is 0.08, exceeding 0.05, implying no significant relation to the target variable. This simply clarifies the dataset structure again. 5 features, x1 to x5, and 1 target, y. Alpha represents my threshold for statistical significance. I'll reject the idea that there's no relationship if my p-value is below 0.05. I use this function from scikit-learn to perform the statistical tests on my features. It's designed for regression problems. The overarching goal is to use the f_regression function to find the features most strongly predictive of the target variable. I'm using a dataset with 5 features, things I'm measuring, and 1 continuous target variable, the thing I want to predict. Think of it like trying to predict house prices, target, based on features like size, location, number of bedrooms, etc. I'm using a statistical function from the scikit-learn library called fregression. It helps me figure out which features are most important for predicting my target variable. It does this by performing a simple regression analysis for each feature individually. The F statistic is a number that tells you how well each feature individually explains the variations in the target variable. A higher F statistic means that particular feature is a better predictor. I have an array of 5 F statistics, one for each of my 5 features. These are the actual F statistic values I got from my analysis. Feature 3 has the highest value, 25.8, suggesting it is the strongest predictor of the target variable. The p-value tells me the probability of getting these results if there is actually no relationship between the feature and target variable. It helps me determine whether a relationship is statistically significant. These are the p-values corresponding to each feature's F statistic. For example, 0.002 is the p-value for feature 1. A very small p-value suggests that the relationship is likely real and not due to chance. I've set my significance level, alpha, to 0.05. This means I only consider a relationship significant if its p-value is less than 0.05. It's like setting a threshold for how much evidence I need. This describes the structure of my data. I have 5 independent variables, represented as x, and a single continuous dependent variable, represented as y, which I'm trying to predict. The overall goal here is to use the fregression function to figure out which of the 5 features are useful for predicting the target variable and which ones can be ignored. I have a dataset with 5 features, things we measure, like height or weight, and 1 target variable, the thing we're trying to predict, like price. This shows how much each feature individually explains the variation in the target variable. A higher number means the feature explains more of the variation. For example, feature 3, 25.8, explains much more variation than feature 4, 0.8. This is the threshold I use to decide whether a result is statistically significant. It means I'm willing to accept a 5% chance of being wrong when I conclude there is a relationship. If my p-value is below 0.05, I'll consider the relationship significant. These numbers tell me the probability of getting the results I saw if there was no actual relationship between the feature and the target variable. A lower p-value means it's less likely I saw this result by chance alone, suggesting a strong relationship. For example, a p-value of 0.002 is highly significant, suggesting a strong relationship, while a p-value of 0.45 is very insignificant. The p-value for feature 1 is 0.002, which is less than 0.05, indicating that feature 1 is significantly related to the target variable. The p-value for feature 2 is 0.21, which is greater than 0.05, indicating that feature 2 is not significantly related to the target variable. The p-value for feature 3 is 0.0001, which is less than 0.05, indicating that feature 3 is significantly related to the target variable. The p-value for feature 4 is 0.45, which is greater than 0.05, indicating that feature 4 is not significantly related and thus can be removed from my model. I'm dealing with a dataset containing 5 input features, x1 through x5, and 1 output feature, target variable, y. I have a dataset with 5 features, things we measure, and 1 target variable, the thing we want to predict. Think of it like trying to predict a house's price, target, based on its size, location, number of bedrooms, etc., features. I'm using a statistical tool called fregression from the SCIKITLEARN library. It helps me figure out which features are most important for predicting the target. It does this by performing individual linear regressions of each feature on the target variable and computes statistics for each. These are the F statistics. Each number measures how well each feature explains the variation in the target. A higher number means the feature is a better predictor. Think of it as a score, higher is better. These are the p-values. They tell me the probability that I'd see these results if there were no actual relationship between the feature and the target. A very low p-value, typically below 0.05, means it's very unlikely that the results are due to chance. Hence, the feature is likely important. This is my significance level, or alpha. It's a threshold I set. If the p-value is below this, then I say the relationship between a feature and the target is statistically significant and likely not due to random chance alone. It's like setting a minimum score. Only features that get over this score are considered significant. I have 5 features, x1, x2, x3, x4, x5, and 1 target variable, y. Again, these features can be different attributes in my prediction problem. In this case, I am evaluating 5. This is the main question. I need to determine which features are good predictors of the target based on the p-values and my significance level, alpha. Let's analyze feature 1. Let's analyze feature 2. Let's analyze feature 3. Let's analyze feature 4. Let's analyze feature 5. I'm using a dataset with 5 features, things we measure, like height or weight, and 1 continuous target variable. The thing we're trying to predict, like house price. I'm using scikit-learn's fregression function. This function helps me figure out which features are important in predicting the target. It does this by performing multiple simple linear regressions. Each feature gets its own regression to see how well it predicts the target variable. X represents my 5 features, and Y is the continuous value I want to predict. For example, X could be things like square footage, number of bedrooms, location, etc., and Y could be the house price. The fact that Y is continuous means it can take on any value within a range, unlike a categorical variable which would have distinct categories. For each of the 5 features, fregression gives an F statistic. This statistic tells me how much variation in the target variable is explained by each feature. A higher F statistic suggests a stronger relationship. Notice that feature 3 has the highest F statistic, 25.8, indicating it's the strongest predictor. Along with the F statistic, fregression provides a p-value for each feature. This p-value represents the probability of observing the obtained results if there were no actual relationship between the feature and the target. A small p-value, typically less than 0.05, indicates that it's unlikely we'd see this kind of result by pure chance, suggesting a real relationship. I've set my significance level, alpha, to 0.05. This means I'm willing to accept a 5% chance of incorrectly concluding that there's a relationship when there isn't one. This is the main question of the exercise. I need to use the p-values and my significance level to determine which features have a statistically significant relationship with the target variable. I check if the p-value for feature 1, 0.002, is less than my significance level, 0.05. Since it is, feature 1 shows a significant relationship. The p-value for feature 2, 0.21, is greater than 0.05, so it's not significantly related. The p-value for feature 3, 0.0001, is way less than 0.05, showing a very significant relationship. Feature 4 has a p-value, 0.45, much larger than 0.05. This indicates it's not a significant predictor and can likely be removed from the model to improve model efficiency and avoid unnecessary complexity.